Today we're going to look at measuring airflow in a system when we set it up, and we're going to do this by taking the external static pressure. You might ask, why are we taking this measurement? Well, with the external static pressure readings, we can determine how much airflow is actually moving through the furnace and air conditioning system. There are two different methods, or two different motors that we use in our industry, and we'll discuss them both and show you how to use each. Now, we're going to debunk any myths that are out there. There's lots of different rumors flying around on how we do it. So Jacob and myself are going to go through the operation of properly taking the external static pressure. The instrument we'll use to take our measurements is called a manometer. Now, L&S has all of the technicians supplied with a digital manometer, and it has two hoses and two probes. The manometer is quite simple to use. We'll get into this in more detail in a little bit. There are two probes. One of the first things I want to talk about is location. For our example, this is going to be our furnace. This is our coil. We'd have a plenum here and a plenum here. Myth number one I want to talk about, everybody thinks the static pressure probe goes in the plenum and the other plenum. That will give us a reading. It will tell us our pressure drop across the entire system. It will not tell us anything about the CFM going through that furnace. The reading has to be taken further or closer to the furnace. It can still be in the plenum or in the, if you take the filter out, that'll suffice. But the critical and most difficult reading to get, we need a hole between the furnace and coil. The data supplied to us from the furnace manufacturer will only provide CFM data on a pressure or on a certain pressure without the coil attached. It is not tested with the coil. So we have to be very careful when drilling a hole in this section. We get too far towards the coil, what do you think might happen? We'll hit the coil. Then we're calling dispatch. We don't want that. You go too far in, we're hitting parts of the heat exchanger. Once we have that data, we can look it up on a table that's supplied with the install manual, and it will tell us exactly how much CFM that unit is producing at that given time. If you'll notice, the probes have a point. It's actually similar, well, it's not a pitot tube, but it's similar. And on the sides, there are holes. Okay? We want the probe to be pointing in the direction of the airflow. If it is pointing to the side and the airflow is hitting one of the holes, we will have an erroneous reading because we'll have velocity pressure, which we're not taking into account. If it's pointing this way, it's just static pressure. So velocity pressure would be added pressure off the blower hitting that, and that would give us an inflated value that's not realistic. But if we keep it pointing in there, the pressure would be a static pressure, that is, it's coming from all 365 degrees, and it's just a true pressure, so it makes a huge difference. So the next thing we're going to do is transition into the attic, and we'll show you test points to take external static pressure, and we'll also talk about two other locations where we take static pressure measurements. Well, now we're in the attic with the equipment that we're going to test. So what we're going to do is talk about our meter and where to place the static pressure tap hole locations. And we have our probes. We have one here, and we have one over here. We're going to drill two holes. Now, I've cheated, and we've pre-drilled these holes, but I'm going to pick up the drill and show you where we would place them. The first hole we're going to put it in the return plenum. Now, earlier I said it has to be right at the back of the furnace or in the furnace after. The key thing is that it is after the filter. And what we'll do, I'll show you, we have our filter door open right now. There is no filter in here. So for this side of the equipment, it's relatively simple. We can put a hole in here. Theoretically, you could put one in here, be the same thing. What we're going to do, or actually we've already done, is put one in the top of the plenum. We'll go ahead and shut this. We're going to take the probe. Now remember, it is direction specific. The main thing, remember Jacob said, always have them pointing towards you. Since this is on the return side, we're going to have it pointing towards the equipment. Notice, it is not hooked to the meter yet, and I'll show you why in a second. Same thing, we just have to make sure that it goes through the insulation correctly and it's pointed towards the equipment. I have both lines disconnected at this time. The furnace is off. What we're going to do is calibrate our meter. This is very important. You can't plug in your hoses, turn the equipment on, and then turn your meter on, because it will assume that whatever static pressure you have is 0. So we'll turn our meter on. We just hit the power button, and then we're going to hit the 0 button. And that's all there is to it. The other thing we have to be careful of is to make sure our units are right. We're doing this measurement in inches of water column. If you'll notice, may be hard to see with the camera, but it does say inches of water column. It does have some metric scales and some other units of measurement, but we need to make sure it's on inches of water column. The next thing we'll do is plug the probe in. Now this meter's nice. It does math for you, and it takes into account negative and positive numbers. And we treat everything as a positive number when we're doing this test. Even if we have a negative number on the return side, which we will, and a positive number there, we add them together. Okay, our equipment is up and running now. We have our blower set at a steady RPM, and we're going to go ahead and take a look at our manometer. The top number is one hose only. The bottom number is where the manometer has done the math for us. So we know our total inches of water column is 0.42, 0.43, somewhere just a little bit above 0.4. Now we've looked at a blower table, and we know that at this given speed at 0.4, somewhere between 0.4 and 0.42, we're running approximately 1700 CFM. This furnace also has the benefit of a digital readout. We can we can use that as a second confirmation, and we're all in the same ballpark. The main thing to be concerned with here, do not use the top number. Use the bottom number with this particular manometer. If you're using a different manometer, we may have to check to make sure you're looking at the right numbers. Let's look at air conditioning tonnages. Every ton of air conditioning requires approximately 400 CFM of air. With 1700 CFM of air going through this, we could handle a little more than a 4-ton unit. If this were a 5-ton unit, we would be shy on air, and we would have to make adjustments to the blower speed. If this were a 3.5 or a 3-ton air conditioner outside, we would have to make adjustments to lower that CFM. We're going to look for kinked ductwork. We've taken the filter out of the equation. The filter is always pulled during this test. So probably our biggest issue would be kinked ductwork. Perhaps some of the install crews left film on one of the registers or on a return. It's in an extreme circumstance, we could have an issue in the evaporator coil with drywall dust. But some of the times you're lucky enough with the ductwork like this, you could find it kinked in the attic. Now that we're all done, we can go ahead and turn off our meter and disconnect, get all of our probes put up in the toolbox. We're going to have to address the holes, and we'll show you. There's a nifty way to do that. You might be thinking, well, why don't you just put tape on them and mastic over? And if we were going to walk away from this system and nobody else was to ever touch it, that would be the preferred method. However, there's a good possibility that an energy audit company will be out here shortly after we've been here. So, we've drilled the holes in mine with little plugs that supply houses sell to patch the holes. They're bright red so people can see them easily, because the energy audit people will come back up here and perform the same test. And they simply plug right into the holes that we've left. And if you've used the right size drill bit, they should pop right in the hole. We'll finish this job by placing the door back on the unit and leave everything ready to go as if the homeowner were to move in. You need to make sure to remember to put the filter back in the unit. The next thing we'll look at will be the paperwork. We'll show you how to fill out the form. Many of you will be doing this online on the iPads. What we're going to do now is fill out the paperwork portion for the airflow test. So we'll be concerned with all of the items 3.1 through 3.8 in the Energy Star design report form. This is on our LNS punch sheet, and we'll fill it out. Now, item 3.1, it asks you, what mode did you test it in? Well, in Texas, we're only going to test in the cooling mode. We're not concerned with the heating mode. So we'll go ahead and mark cooling. Number 3.2, static pressure test holes have been created. Well marked and accessible. And where are they? Well, in this particular test, we used the plenum. So we'll simply mark plenum. Just put a P. Test hole location for external static pressure. Test hole location for return external static pressure. Well, for both of these, we'll put P down as well again. Now, measured external static pressure, value only without the negative sign, and measured supply external static pressure, measured value only without the negative sign. Remember, there are no negatives and positives. In this case, our total external static pressure, we were running 0.65. So one of them was running at, I believe it was the external return was running at 0.30, and our supply was 3.5. Then our total, we simply add those two together. Our meter did the same thing. It was 0.65. Measured total external static pressure on the design report. Simply put, that you'll get that off your iPad. All of the superintendents will have access to that. What was the system designed to? When the design team designed it, what was their external static pressure designed up to? And we designed for anywhere from 0.75 to 0.8. So we'll put 0.75 there. Then line 3.7, measured fan airflow. Well, with that external static pressure on that speed setting, we looked up in a blower table, and it told us we were running approximately 1,650 CFM. Item 3.8, the measured airflow. Was it within 10 or 15% plus or minus of the designed airflow? Well, this was a 3.5-ton system. We're at 1,650 CFM. We're a little on the high side, but we're there. All right, once you've got your completed report, now for this tutorial, we don't have the top filled out yet. When they finish the startup, they will. But this report will then be submitted to customer service daily.